Today we're going to be looking at the Unit 4 extension, Math Magic. So since this is an extension, this will be worth honors credit as well as extra credit. So our objective today is I can model math magic as an expression in 3 out of 3 problems. So we're going to look at what we mean by math magic. And there is a formative for today. You won't want to get this off the video. You'll probably want it from the link in class. So go check out class for the link in formative. And we will get started. So we're going to use math to read your mind. So you may want a calculator for this. You're perfectly welcome to use a calculator. You could use Desmos if you like, or a handheld calculator, whatever works for you. Or you can just do this in your head, write it down on paper, anything that works for you. So first we want you to pick a number between 1 and 10. Pick a number, write it down. I will work along with you. Okay, next step is we're going to subtract 1. Write down the new number. Then we multiply that number by 3. Then we add 12 to that result. Then we divide that result by 3. Then we add 5. And then we subtract our original number. So since you wrote it down, you can go back and look, what was your original number? Subtract that. And now the number you are thinking of is, was it 8? How did we know that? How did we know it would be 8? So no matter what number you started with, we went through those steps and we ended up with 8. How did that work? Let's take a look and see if we can model that with algebra and see if we can answer that question. So here are the steps again. They're laid out in a table. And now we're going to write each step as an expression. So first we pick a number between 1 and 10. And since we don't know what the number is, we like to put unknowns in variables, right? So maybe we could just call that x. So that's why we've written x over here. And then our next step was to subtract 1. So that's just x. We started with x and now we subtract 1. So we're going to go through each of these steps and do these calculations as an expression and see what we get. So first step, we're going to multiply by 3. So we'll take 3 and multiply by the whole previous step, x minus 1. Next step is to add 12. Okay, so 3 times x minus 1 plus 12. Then we're going to divide that whole thing by 3. So all of that over 3. Here we go. 3 times x minus 1 plus 12 divided by 3. Then we add 5 on top of that. Remember, if we just add 5 to the result, it doesn't go in the fraction. It goes over here at the end because we're just adding 5. And our final step was to subtract our original number. Now our original number we called x. So that means we're going to subtract x from this whole complicated thing we've got up here. So I just bring everything else down, plus 5 minus x. Okay, so that's our big complicated expression from all of those steps. Second part, they want us to simplify this expression. So let's look at this down here. Do you see any places that we could simplify something? Well, I see parentheses, so parentheses are always a good indicator for me that I can do distribution. So maybe let's start there. Let's start with distribution on top of that fraction. So I'm going to distribute the 3. I get 3 times x is 3x, and then 3 times negative 1 is negative 3. And I bring everything else down. But now look, I can simplify this bit. Minus 3 plus 12, let's see, 12 minus 3, that's going to be 9. So 3x plus 9, right? Because we've got a plus 12 minus 3, it's positive 9. All that over 3 plus 5 minus x. And then we can see that when we divide, this has to go into each of these upper numbers in the numerator. So we're going to divide that by 3 and divide that by 3. 3x divided by 3, that'll just be 1x. And then 9 divided by 3 is 3. We bring everything else down and look at what we get. X minus x, those will cancel, and we're left with 3 plus 5. This equals 8. So with all of these steps combined, the x's ended up canceling, and it didn't matter what number we started with, we always ended up with 8. So that's how we knew that you were going to get that answer. We knew you were going to get 8 because it didn't matter what you started with. So in part C it asks, would you still get the same answer if you picked a negative number instead of a number between 1 and 10? What do you think? Are there any of these steps over here that say you can't use a negative number? Maybe let's try a negative number and see if it works. I'm going to try a different color over here. So say we don't pick a number between 1 and 10. Let's try like negative 4. That's a negative number. Start with negative 4. Negative 4 minus 1 will be negative 5. Multiply that by 3, we'll get negative 15. Add 12, we get negative 3. Divide by 3, okay, that'll be negative 1. Then we add 5. Negative 1 plus 5 is positive 4. And then subtract our original number. So we have 4 minus, our original number is negative 4, so 4 minus a negative 4. Subtract a negative is add a positive. We get 4 plus 4 is 8. We got the same answer. It still worked when we tried a negative number. And you can try the different numbers we've talked about before. You could try 0. You could try a large number. You could try a fraction. You could try any of those and see if they work. And it turns out that it doesn't matter what number we put in for x, because all of these steps are valid. All the way down, all of these steps are valid no matter what number we use for x. Because we haven't introduced any contradictions or any rule breaking. Most of the rule breaking we see are divide by 0. We don't see any of that. So the answer is yes, any number we pick will simplify to 8. It doesn't matter if it's negative or positive or between 1 and 10, a fraction, any of those numbers will simplify to 8. So now we're going to take a look at a more complicated one, and you will definitely want a calculator for this one. So once again, you can use Desmos, you can use a handheld calculator. Okay. And the key thing here when you're using a calculator is that you need to press enter between each step. So our first step is I'm going to enter my birth month into my calculator. So I was born in November, that's month 11. January is 1, February is 2, and so on. So enter your birth month, press enter. Then we're going to multiply that by 4, press enter. Then add 13, press enter. Then we multiply by 25. Press enter. Now we're going to subtract 200. Press enter. Now we need to add the day of the month you were born. So what day of the month? I was born on the 7th, so I'm going to add 7, but you need to add whatever number you were born on, whatever day. press enter. Now we're going to multiply this by 2, press enter. Subtract 40, press enter. Multiply by 50, press enter. And now we need to add the last 2 digits of your birth year. So for instance, if you're born in 2004, you would add 04. If you're born in 2005, you would add 05. And so on. Okay, so I'm going to add my last 2 digits of my birth year and press enter. And our last step is subtract 10,500. Press enter and take a look at what's on your calculator. What do you see? What do you see shown on your calculator? Does that number look familiar or interesting in any way? So this is what mine shows me. And that's actually my birthday. And it's showing me this number on the calculator. How did it know? How did it do that? Do you think maybe we could figure that out from algebra again? Could we use expressions to figure out how they did that? Let's try it. Let's take a look. So once again, we've listed out the steps in this math magic trick. And our first step was to enter your birth month. And once again, we don't know what the birth month is. It's an unknown. So maybe we'll give it a variable m for month. And then our next step is to multiply by 4. So 4 times m, 4m. And then we're going to add 13, 4m plus 13. Good so far. Multiply by 25 next. Okay, so 25 times this whole thing. We need to put it in parentheses. And maybe to make this easier on ourselves, let's simplify this as we go rather than trying to do that all at the end. So we have parentheses, which means we can distribute. We can simplify this. 25 times 4m, that'll be 25 times 4 is 100. M, and then 25 times 13, I don't know that one in my head, I have to put it in my calculator. 25 times 13 is 325. Okay, next step is to subtract 200. So I'm going to do that right here so we can combine these like terms and just add straight down. We get 100m plus 125. 325 minus 200 is 125. And now we're going to add the day of the month you're born. Now, there's another unknown, right? We don't know what day the person was born. So maybe we'll use a variable for this. Day, maybe the variable d. So we'll do 100m plus, that actual 0, plus 125 plus, now we're adding the day they're born. All right, now come up here. Next step was to multiply by 2. Okay, so we have 2 times 100m plus 125 plus d. Oh, it looks like we can distribute again. Do some simplification here. So 2 times 100m is 200m. 2 times 125 is 250. 2 times d is 2d. All right, our next step is to subtract 40. I'm going to write that right here once again so we can just easily add straight down. I get 200m. 250 minus 40, that's just going to be plus 210. And then the 2d comes down. We didn't do anything with that. Now we're going to multiply the whole thing by 50. We only have a few more steps. Let's keep going. we multiply this whole thing by 50. And I see parentheses, which tells me I'm probably going to do distribution again. 50 times 200. Let me put that in my calculator. I get 10,000 M for that distribution step. 50 times 210, that's going to be 10,500. And then 50 times 2D, I think that's going to be 100D. So that's what we get after we distribute that 50. Our next step is to add the last 2 digits of your birth year. That sounds like another unknown to me. We're going to have to assign a variable. How about Y? Y for year. So now we just add that onto the end. 10,000 M plus 10,500 plus 100 D plus Y. We just add Y right onto the end. And then our final step here is to subtract 10,500. Well, let me line that up with its like term and look at this. 10,500. Those will cancel. Those will just completely cancel out. 10,500. And we end up with 10,000 M plus 100 D plus Y. So that's our result. That's what you saw in your calculator. But now the question is, how does that translate to this number I saw? Why is it formatted like this? Well, here's a question for you. What happens to a number when you multiply it by 10? I'm going to move up to the top here where I have some room. If I start with the number 11 and I multiply it by 10, I get 110. If I multiply it by 100, I get 1100. If I multiply it by 1,000, I get 11,000. And maybe you see a pattern here where we just add that same number of zeros. We multiply by 100, 2 zeros, I just add 2 zeros. Add 3 zeros, add 4 zeros. Whatever we're multiplying by, we just add zeros. So basically, we're just shifting this 11 over. We're just shifting it over and over and over and putting zeros at the end. So when we multiply by 10,000 down here, 10,000 times the month, we get 11 and then 4 zeros after it. Same idea with the day. The day for me was 7. I get 7 with 2 zeros after it. So we'd end up with 11 with 4 zeros plus 7 with 2 zeros. And then finally I add the birth year. You can see when we add those all together, we get zeros plus the birth year, zeros plus the birthday, zeros plus the birth month. So that's why it comes out to be that format. It's because these multiplication factors, 10,000 and 100, moved the number over. It shifted it over. So I'll just write that down here. Multiplying by 10,000 and 100 shifted the month and the day over. So when you add them all together, you get a number that's formatted like this. All right, so we've seen a couple of examples now of these math magic tricks. And now it's your turn to write your own math magic trick. So for your first step, you'll want them to pick a number between 1 and 10. And then your trick should have at least 5 steps. And then you always want it to result in the same number. Can you think of some steps that will result in the same number? Pause the video, try to come up with some. Play around with it. See if you can figure something out. Okay, so did you come up with something? Did you find one? If not, maybe let's try one together. Let's see if we can figure something out. So pick a number between 1 and 10. We remember that's going to be a variable, right? We can just call that x. And maybe let's do something to that x. We have choices of add, subtract, multiply, and divide. Maybe let's multiply this one by 4. So this was my step 2, multiply by 4. And now I want to subtract a number. Let's try subtracting 36. So now I get 4x minus 36. And now let's divide by 2. Notice these are both divisible by 2, so that should go just fine. 4x divided by 2 is 2x minus 18. And now let's see, maybe let's multiply by 3. I get 6x minus, what is 18 times 3? 54 minus 54. Okay, so now I've definitely got myself all wrapped up in a web of expression here. I'm just going to untangle it by undoing these numbers. I'm just going to add 54. That'll get that 54 out of there. So 6x minus 54 plus 54, we get 6x. And my last step, I'm going to divide by x. So divide by my original number. So now if we have 6x divided by x, we should get 6. No matter what number we chose, and there's one exception though. They can't choose 0. We can't divide by 0. So make sure when your person picks a number, do not let them choose 0, but any other number is okay. And we should get the number 6 as a result. Now, have you thought of a different pattern than that? That's totally awesome as well. You saw that I just kind of wound around and added some numbers, subtracted some numbers, multiplied, divide, and then tried to get back to just a single number. So that covers today's objective. I can model math magic as an expression in 3 out of 3 problems.